So we're working on a principal agent framework. So we have agent Bob, Tweedledee, and we have principals, Alice, the Mad Hatter, and Rabbit. Agent Bob has a set of strategies, S, and each principal has an evaluation for each strategy. Now, the principals offer the agent a contract which determines the payment or the transfer they're going to give for each strategy the agent chooses. We could imagine an agent is the mayor of a city, and he's thinking he has strategies either to make a playground or add parking spaces, and Principal Alice is a school, and the Mad Hatter is a family with children, and the Rabbit is a restaurant, and each one has a different evaluation for the strategies, whether it's parking spaces or the playground. So they'll offer different contracts for each strategy. Now, this is an extensive form game because initially the principals offer contracts, and only then the agents choose strategies. So we're looking at the subgame perfect equilibrium as an SPE. Most of the literature has looked at first price contracts, where the principal offers a price, a payment, and pays that payment to the agent if the agent chooses the specific strategy offered for that strategy. An example is the common agency with many principals and one agent, as in our example by Bernheim and Winston, where the contracts are basically first price. And another example is many principals and many agents by Prat and Rustichini. Our framework is based on their paper. And let's look at their paper. We have many principals and many agents. We call it a GPTA, games played through agents. So we have M principals and N agents. So look, we have two agents here. Each agent has a set of strategies. And an outcome is a set of strategies where each agent chooses a specific strategy. And each principal has an evaluation for each outcome. Say agent 1 chooses strategy S sub 1 sub 1, and agent 2 chooses strategy S sub 2 sub 1, then that's an outcome. So she has an outcome, an evaluation for that specific outcome, and for every other outcome as well. And so do all principals. Every principal will give a principal bid for each strategy. PB for principal bid for each strategy. The agents see these principal bids, and they know what the contract is, and they choose the strategy accordingly. Now, the first price contract, at this stage, the principals pay the agents transfer according to the contract and the principal bid that they said. So in the first price contract, the principal M would pay agent N for choosing strategy SN, the bid that she actually offered. Okay, for example, let's look at an example of the game. Here's the game. It looks like the prisoner's dilemma, but it isn't, because it's a different framework. So we have two agents here and two principals. Agent 1 has two strategies, top and bottom, and agent 2 has two strategies, left and right. And the numbers in the middle are the principals' utilities from each outcome. A number of them left in each cell is principal 1, and number on the right is principal 2. So the subgame perfect equilibrium in this game is TL with specific principal bids PB hat. So that's a good equilibrium, a good subgame perfect equilibrium because it's quite efficient. What principal bids bring us this subgame perfect equilibrium? These PB hats. Why is this an equilibrium? Because if the agents obviously have no incentive to deviate, because agent 1 is being offered 2, whether he chooses top or bottom. And principal 1, for example, in this point is attaining is attaining 2 for outcome TL minus the payments of principal bids for T and for L. That would be 4 minus 2 minus 0 equals 2. So principal 1 is attaining 2, and she can't raise her utility in any way. another example, this example, again, 2 agents, 2 principles. Turns out that for any C, there is no subgame perfect equilibrium in this first price contract setting. So basically, first price contracts can limit the possibility of some outcomes we would like. Say if C were 1 million, it's a shame that there is no subgame perfect equilibrium in this game. To get some more intuition of the framework, basically a special case of the GPTA setting is a simultaneous first price single item auctions. Why is this a special case? Basically, the agents in our setting would be the sellers. Each agent would be selling a single item. The principals would be the buyers. Each buyer is interested in buying a set of items. Each agent's strategies would be to sell their item to a specific buyer. Say S11 would be selling agent 1's item to principal 1. And each principal has an evaluation for each bundle of items. So you can see that, I've got my button here. Where is my thing? There it is. Does I have a thing here to press? Oh, this is what I wanted. Doesn't matter. Alice's evaluation from the first bundle we have here is basically having item 1 and item 2. But from the second bundle, the second bundle is actually just item 1, because agent 1 would be selling his item to principal 3 in this case. Okay, and the principal bids in our setting, they're the principal bids we talked about, and the auctions, they would be the bids. And the transfer in the auction setting would be the payment that the principal bid pays the agent for whatever action the agent chooses. So it's nice that we can see the simultaneous first price auctions in the case of first price contracts in the GPTA setting, but we can't see second price contracts in this setting. Because basically second price contracts depend on other offers, other principals' offers. So we can't see the second price auctions. So what we did, we proposed another contract called principal agent VCG contracts, which we can see the second price auctions through that contract and also other things. Basically looks at the framework that we saw through this second price eyes. Now, these principal agent VCG contracts, they significantly expand the set of games which have a subgame perfect equilibrium. Many games do not have subgame perfect equilibrium first price contracts. In these contracts, some of those games do. And they do this while not increasing the price of Anarchy. And they are simple contracts. So basically, what do we do in our analysis? We analyze these VCG contracts. We characterize the subgame perfect equilibrium through a new notion of unitary balanced weights. We analyze the measure of the set of games which have subgame perfect equilibrium, but which in the VCG contracts, but did not in the first price contract. And we analyze the price of Anarchy. I'll speak of some of these results. So what is the VCG contract? This is the VCG contract. It looks a bit complex. So T, the first T is for transfer. The T in the VCG is that principal M will pay agent N for choosing strategy Sn is equal to. So basically, what is equal to? What is the agency? The agent sees this first and second term. This, the agent sees, is constant. Has nothing to do with the agent's choice. Has nothing to do with whichever strategy agent N will choose. So agent N sees that he's going to be paid from principal M, basically the bid principal M says. So agent N is going to just react to a first price contract. Agent N will maximize the sum of bids for his strategies. So what does principal M see? Principal M, of course, knows what agent N does. Principal M knows that agent N is going to, if agent N chooses Sn, then principal Sn hat And the principal knows that this term is equal to the sum of bids on the chosen strategy. So this is what principal M sees. Now principal M subtracts the third term from the second term and sees this equation. This is what principal M is going to pay agent N. Now this looks very much like the VCG payment rule, which is nice because it means we have all the VCG payment rules properties. So what's the connection between the VCG payment rule and the VCG contract? So the M would be the players in the VCG payment rule and the principals of the VCG contract. Different names. The N, the mechanism designer, would be equal to 1, and agents, we'd have a few agents. SN would be the alternatives or the strategies in the VCG contract. PB is the principal bids, the bids or the principal bids, the values in the VCG payment rule. Now, the main difference between them is this difference. The SN, the chosen SN, which maximizes the sum of PBs, in the VCG payment rule, it maximizes the social welfare. That's what the mechanism designer chooses, is maximize the social welfare. The mechanism designer has no interest in his own payoffs. In the VCG contract, the mechanism designer it's not a mechanism designer, it's an agent who is interested in his own payoffs. And the transfer is again the same transfer in both, Okay, the transfer is the same transfer in both mechanisms. So what's the difference between them? As we said, the agent N is not a mechanism designer, but a strategic player. And the strategic player is interested in his own payoffs and is not interested in the welfare. Another difference is that principals play multiple agents, not a single mechanism designer. And the principal's value is determined by a set of strategies, not a single strategy. Now, the second and third issues have been dealt with in simultaneous second price auctions. That's been tackled. But the first issue here has, to the best of our knowledge, has not been dealt with. Whatever. Okay. Another property is no overbidding. No overbidding is an equilibrium refinement. Basically, it means that you can't offer more than the sum of bids for a specific outcome can't exceed your evaluation for it. Now, this is important basically because otherwise we don't have no overbidding. Then, if you don't have no overbidding, then we could attain practically any outcome and pronouncing high enough bids. Yes? Oh, I have 5 minutes. Oh, okay. Turns out that every subgame perfect equilibrium in the first price contract is also a subgame perfect equilibrium in the VCG contract, and it satisfies no overbidding. So from here we can learn that the set of games which have subgame perfect equilibrium in the VCG contract includes the set of games which have subgame perfect equilibrium in the first price contracts. But this inclusion is strict and even has positive measure. An example for a set of games which have an equilibrium in the subgame SPE in the VCG contracts and do not in the first price contracts is this game that we saw earlier with 2 agents and 2 principals. So it turns out for any C that is higher than 1, it does have an SPE in the VCG contracts. Let's carry on. So we saw that there are many more subgame perfect equilibrium in the VCG contracts. The question is, maybe this harmed the price of Anarchy. But it did not. The price of Anarchy is basically the same in both situations between M plus 1 and M. If we have a game with M principals and a VCG contract or a first price contract, in both situations, the price of Anarchy will be between M plus 1 and M. So here's an example, but we won't go into it. Okay, conclusion. So what did we do? We presented a new form of VCG contracts, which for multiple principles and multiple agents. These contracts have many more subgame perfect equilibrium than first price contracts, but do not harm the price of anarchy while doing this. Further possible research. It would be interesting to analyze the subgame perfect equilibrium over mixed strategies, to analyze the VCG contract if agents have preferences over their actions, to analyze the complexity of the first price contracts or the VCG contracts, and to analyze the subgame perfect equilibrium if principals or agents could actually choose which contract to choose, if they could do the first price contract or the VCG contract. And it would also be interesting to analyze the notion of the unitary balanced weight, which we introduced to analyze the subgame perfect equilibrium, and see what the connection between that and the Scarf's notion of balanced weights is. Thank you.